remember to do this here, we're recording. So economists organize themselves into schools of thought. And the SDers thought back in the day that economists just didn't like system dynamics, all economists. And I came along and said, no, 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 some economists, you have to talk to the right economists. You have to talk to economists who do economics in a school of thought whose principles mesh nicely with system dynamics. And I said, here are the schools of thought and what have you. And so given our feedback economics book, I think I told the story, Springer wanted us to do a second edition. Nobody had the energy to do it. And my position was, look, if it was a one-off thing, we've done it, we're done, have a nice day. But if the feedback economics book was the first or the foundation of a whole area called feedback economics, then we have to do more. And then people were like, well, what do you mean exactly by that? And I started to write up, if you remember the story, a message, and I'm like, geez, I'm writing a paper. I might as well just write a paper. So remember, there's the three matrices, and we're going to get to these in here. The social fabric matrix, the social accounting matrix, and the Godley table, which is a matrix, right? And they are used routinely by different schools of economists, economists who live and work in different schools of thought, right? The Godley matrix is used by post-Keynesians in the stock flow consistent modeling camp. The social fabric matrix, Greg Hayden, is the institutionalist camp. And the social accounting matrix folks are called the structuralist school of economics. Okay, and so I'm always picked on by Steve Keen, who is an economist who essentially does system dynamics, but keeps trying to get me to not use Stella, but instead to use his software called Minsky. And his argument is, hey, Minsky allows you to do Godley tables really easily, which is true. But yeah, you guys in the SD really can't do Godley tables. And I was like, yeah, we can. Who says we can't? And I started to try and do it. And I was like, oh, it is a little tricky, but I had Kareem and Billy help me from IC Systems, and I know how to do it now. We'll talk about that later in the course. But then I started thinking, as we're trying to get economists to use system dynamics, right? So the more you show them that our stuff corresponds to their stuff, rather than, hey, we're smart and you're not, and we're going to save you and show you how you're wrong, that doesn't play. But if you can say, hey, you guys do all this, well, we do that too, and we have tools to do that, and so we might consider working together, right? So I started thinking about these three matrices, and my current thinking is two of them are after you build a model to help you verify it, find out whether it's valid, build confidence in it. So the Godley table and the social accounting matrix are similar but different, and that's after you build the model. But I think the social fabric matrix can be used before you build the model, during the conceptualization process, right? And at the doctoral seminar, I gave a little example. Aubrey was kind of working the mouse, how I just made up some I think ABC or whatever I said, and we made a little pretend social fabric matrix, and then I showed everyone how to turn it into a causal loop diagram. We ran out of time. From the causal loop diagram, you would build a model, right? A simulation model. But the value in the social fabric matrix is it gives you guidance as to where to look for the important stuff to put in your model, because we're trying to put the important stuff in our model and leave out the unimportant stuff, unimportant to the problem we're modeling to address. So we're not trying to build a digital twin. We're trying to simplify the world with a model, right? Well, how do I do that, right? And we said, well, there's various traditional techniques, the hexagon method with the Post-it notes and whatever, and that's fine. I mean, no harm in that. But the social fabric matrix is something that you could slap up, and there's these broad categories, technology, environment, culture, and all that. And within those categories, which probably are sectors or possibly super sectors, there are variables or possibly sectors, depending on the amount of detail and how you conceive of it, right? But it helps guide the conceptualization process. Well, what should I put into my model? What should I leave out of my model? And how do they interact? Do they interact with one another? Obviously, in system dynamics, we're looking ultimately for feedback loops, right? So I think the social fabric matrix is the first of my 3 matrices I want to talk about in my paper. I think that can be used by system dynamicists for model conceptualization. And oh, by the way, that should make the economists I'm trying to talk to happy because we're using one of their tools, right? And the only people who have ever even talked about this are me and Rod Gill, right? If you remember, but there was that book and whatever. I mean, Fulwiler, who was one of the editors of the book, is an economist. So there's others, but it's very, very few of us. Okay. So we kind of left the doctoral seminar like, okay, there's this tool, it's a matrix, it has these categories, you kind of find stuff. Rod Gill was looking for beekeeper stuff, the beekeeping industry in Australia as an example, and what have you. Okay, and sort of is like, so okay, what's the details on how you do this? And it's not clear. And now the human being has to get involved and think about it and all that good stuff. All right, so why am I telling you all this? You kind of know this. I just wanted to recap it. So let me show you what I did since last we met. Bear with me. All right, can you see that? There's a Microsoft Word document. Can everybody see that?
Yes.
Ah, excellent. So I said to myself, because I'm the only one who really listens to me at my house, what happens if I try to use artificial intelligence to help build a social fabric matrix? Because think about it. If we're trying to get a handle on some problem area in society, and we're trying to map out the important aspects of the fabric of society that impacts a particular problem, right? That's kind of a big task, right? We got environment stuff, we got econ stuff, we got cultural stuff and so forth, right? Let alone the interactions. So how do we even identify all that stuff? Well, you know, you can maybe the area beekeeping is your thing. SD and beekeeping, you do both at a very high level. So you know all about the domain of beekeeping. So you just use your knowledge and there you go. But often it is the case that you're a good modeler, but you don't know a lot about, maybe you know a little, but not a lot about the domain area. And you're going to work with experts and stakeholders, right, to help you identify the important stuff. Okay. And you can use the hexagon method. You can use a social fabric matrix and they'll tell you. But what if you're working on by yourself? Let's say you're doing a doctoral dissertation and you're not really, I mean, you could for a dissertation, you could work with experts and stakeholders, of course, but let's say you're in your lonely cubicle working on some problem, some domain area, right? And you're saying, geez, there's a vast literature here, including meta-analyses, right? Where people have sort of summarized or tried to find, you know, all the different people who have studied something, and they've said, let's find the sort of a summary of all the important things that have been identified in the case of a particular problem. Sometimes they're contradictory, right? That's very common. This is part of your literature review, right? What if we asked AI to help us? Okay. Now, again, think about it. Let's just tap the brakes right there. This is something that would be a contribution for a dissertation paper. If some of these sorts of details were fleshed out and you'd write a paper, a how do you do it paper, and you showed others, right? So this is a food for thought for doctoral students as well. Like, okay, you know, he's going to show me something, but maybe, okay. All right. So what did I do? I took Rod Gill's paper and I had to turn it from a PDF into a text file, and I fed it to ChatGPT. And then I said, can you read this, Rod Gill paper, and build me a social fabric matrix from it. And it said, sure. Okay. Based on the detailed information provided, I just copied and pasted his paper into the thing. I didn't include the figures, and the thematic elements discussed in Roderick Gill's paper, we can construct a simplified social fabric matrix. Okay. Elements of the social fabric matrix: institutions, technology, environment, beliefs and attitudes, values. Okay. And then it says, all right, government bodies, industry groups, beekeeping, crop production technologies, land use, whatever, blah, blah, blah. So at this point, I'm going, okay, it's reading the paper. Cool. And then here's what it came up with for the matrix. Remember, a 1 means there's an interaction. It doesn't traditionally do polarity plus or minus sign. Now, if you look at this thing, everything affects everything. The diagonals are blank and everything affects everything. So it's a crappy social fabric matrix, but I didn't already tell it what a social fabric matrix was. It went out and figured that out, and it read the paper, and it's getting the right sort of sectors or super sectors. So, all right, it's hot on the trail. Remember, you got to train these freaking things, right? All right. So, and it says that 1 indicates the presence of a direct relationship or influence, right? Empty cells, less direct or undefined. And then it gives explanations of what it means. I didn't ask it for it. It just did this. Okay, blah, blah, blah. Okay. It provides a snapshot of what's going on in Gill's paper. So then I said, can you be more specific about the variables in each of the categories? I'm not going to let it off the hook. It goes, certainly, with an exclamation point. Okay. So now it's given me, what does it mean by institution, government, regulatory bodies, blah, 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 technology, blah, 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 blah. Now it's going to build the social fabric matrix. Okay. Wah, 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 wah. Yeah, not really the greatest. I mean, I was assuming it was going to take each of these things, growers trust, whatever, and it would be in here. These things fleshed out. There'd be subcategories here, right? Like in a regular social fabric matrix, and it didn't do that. Okay, so, and then it gives explanations again and what have you. All right, so now, by the way, I did the same thing with Copilot. Does anybody know what Copilot is?
Microsoft's.
Now, what I don't understand is Microsoft partnered with ChatGPT or OpenAI, right? That does chat, but they have Copilot. Is that their version of OpenAI's?
Yeah, a lot of different versions.
Okay, so whatever. So I tried it with another AI, large language model, whatever they call these things, tool, and it did not as good. Okay, again, not horrible, not like ridiculous, but just not as good. So thus far, my conclusion is this is probably possible, but that we got to train the thing, or somebody who knows more about this stuff needs to work on this, because I don't know bupkis about. I'm just kind of telling you everything I know about it, which is not a lot, right? However, I said, all right, I'm curious. And so I thought, well, maybe Rod's description was too elaborate, too vague, too whatever. I don't know. And I didn't give it a meta-analysis. I didn't give it 5 papers or 15 papers. I gave it 1. So I thought maybe I should give it something more modest in scope, but vivid, and see if it can do it. So I thought, what the heck is modest but vivid? And I thought, aha! 'Twas the night before Christmas, and all through the house, not a creature was stirring, not even a mouse. Ennis, are you familiar with this? I guess this is a poem, right? Is this a poem? Technically a poem? I'm not a poet or whatever. It's not really a story. It's a poem, right? Or a narrative. I don't know what the hell you call this thing. And I'm not sure when they did. This is from like the 1920s or something. I don't know. It's like 100 years old. So Ennis, are you familiar with this?
No, no, no,
Okay.
no.
So in America anyway, and probably in some other Western nations, we do Christmas, we do other stuff, but Christmas. And there is this famous, let's call it a poem about Santa Claus. Have you heard of Santa Claus? Who Santa Claus is? Ennis?
Yes, yes.
Okay, so it's all about Santa Claus coming and delivering gifts and what have you. Okay, and it's very, 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 very famous in the U.S. It's been around for like 100 years or whatever. Okay, so I fed Chat GPT. 'Twas the night before Christmas, and then I said, make me a social fabric matrix. So here's what it came up with. The elements, okay, there's family members, there's Santa Claus, the environment, inside and outside the house, there's a reindeer team, objects and symbolism, there's stockings, the sleigh toys, temporal setting. The time is the night before Christmas, and it's quiet and festive. And it came up with this for a social fabric matrix. Okay. So again, it's a little more detailed here. It's not just a one or a blank.
It also has like the actions, which is that describe the relationships,
Right. So correct. So it's
or
coming up with
or
more.
structural. Yeah. So it's interesting.
Right. Right. And then it
Not
tells
just that, oh, yeah, these things have something related to each other, but doesn't tell you anything else.
And
right.
it kind of has an ideological column, that one on symbols. It tells you what they're affected by gifts. It almost tells you their ideology, you know?
Right, exactly.
Very cool.
I got a
Very cool.
weird air conditioning unit in here that makes a sound. I'm sorry about it. I'll turn it off and see if it'll stop doing that. Okay.
Just a quick note. The poem's 201 years old.
Oh, 201. Okay, yeah. So super old, super famous in the United States, whatever, blah, blah, blah. Okay, so it's not like I spent 73 hours dwelling on this. I was like sitting here going, what would be modest in size but vivid? And I was like, oh, night before Christmas. All right, whatever. There's probably something better, but anyway. Then I said, can you create me a causal loop diagram from the social fabric matrix? I don't know. What the hell? Well, I'll ask it and see if it can do that. Okay, so it figured out what a causal loop diagram was. So it's saying, well, here's elements and relationships. Okay, and then it says, well, here's how you do a causal loop diagram. Okay, and then it gives an example. Okay, and then I said, well, let me just see if I can figure out, based on what it is telling me, would be, because I was like, well, this is hot on the trail, but let me, so this is kind of, I took the variables that it identified, and I kind of came up with this diagram. Okay, so it found some loops. There's a lot of some one-way causality stuff in the thing, but exogenous. But overall, it's like, all right. There's probably something here, right? And then I said, what if I let Copilot try? Because I let Copilot try the other one too. And so it came up with the ones and zeros thing here. And it came up with the narrator. I thought that was interesting. And then objects. Okay. And then I said, can you redo the matrix, adding more detail about the objects? Because it's just like objects. Well, what do you mean by objects? So it goes, certainly. It's always just damn glad to help you. So it came up with these objects from the poem, which is all correct, right? And then it came up with a more elaborate social fabric matrix. Okay. And I asked, I forget what I asked it here. I said, basically, give me some more interactions or something, because I didn't copy and paste whatever I asked it to do. But I asked for more detail, right? And it did that. All right. So before pressing on with other stuff, what do you think as doctoral students who got to do original work? Yeah, Suzanne.
I'm going to rain on your parade.
Okay, throw a bucket of water on my campfire.
I think that I've spent a lot of time thinking and drawing and writing about this, and I've read the paper. And if we're really trying to develop a process for organizing complex data to bring that information into to help us develop causal loop diagrams and then to develop stock and flow diagrams, I think the SOAP process has more benefits because I've gone through this whole thing. And what's interesting is in this paper, when they go back to say why it works, they always go to some medical analogy. I just thought, isn't that interesting? First, it was gallstones, and then it was something else. Because I have tried to take medical information and have done it with oncology, veterinary oncology, and put it into a matrix like that. And what happens is then you have to decide, if you're trying to automate this whole process, which factor has more influence over the systemic performance. And then you have to weight the factors, and there has to be some sort of basis on which you do that. And it gets very clunky in a matrix. It doesn't work well. And that's the
This is
beauty
SOAP
that I see.
process?
Pardon me?
This is the SOAP process that gets.
Well, no, I'm saying the SOAP process has the ability to do what you're trying to do as opposed to a matrix.
So what would you, well, let's spitball a little bit here. If I said, your assignment for next week, Suzanne, is take Twas the Night Before Christmas and ask ChatGPT to analyze it from a SOAP perspective, you think that's possible?
No, because I don't think Chat GPT at this point in the game is going to be helpful. Maybe at some point in the future, because I have tried to take a medical process and put it into a matrix, and I worked for 5 years on that. And I know the flaws in thinking that come up with that, and that the SOAP system, even though it relies on my brain and not a computer, is actually more accurate and more reliable. And that's the art of the process.
Now, I can tell you,
Huh?
I was gonna say, I can tell you what Jay would say, because I
What would he
had
say?
many conversations with him about this, or listened in on conversations with him when somebody else asked it. And he's like, he would hate it, because he said the point is for you to learn and to think through these things, not for some freaking machine to do it for you, because then you're not learning.
Well, and I will tell you that I have to sit down and write a SOAP to help me think through a really complex project, or a complex, trying to deal with an animal that has thyroid disease, it's diabetic, and now it's been vomiting for so long, and there's hardly any parameters on its blood work that are in the normal range. And the way I sort it all out and figure out which thing is most important is by sitting down and writing a SOAP. So I think there's value in, especially when we're talking about society, there's value in seeing if the SOAP process can be adopted into system dynamics, because that is exactly this process. Is when I saw system dynamics in 2013, I went, oh my gosh, this is what we did not have when I was doing that veterinary oncology project, where we could have done it instead of spending our years of our lives frogging around doing a matrix in Excel. So I think there's more value.
I can smell a paper by Suzanne Parcel-Dew titled, applying the SOAP process to system dynamics modeling, a blueprint, in the SD review.
This reminds me of when I was getting ready to go to veterinary school, and the year before I was doing neurologic exams on rats all day long to put food on my table. And my boss said, this is great. You know more about normal rat behavior than any person I've ever dealt with. You need to write a paper on this. And I said, I don't know if I want to be known as the queen of rats.
Ben and Willard. Yeah.
So, but so I have just an opinion on, I just looked up SOAP a little, not just a minute ago. I looked up last week. I was looking at it a little bit. One of the things in SOAP, I think it collects a lot of the same information, but I think what the social fabric matrix is attempting to do is to start connecting which things have relationships. You know, so that will allow you to start to tease out some of the causal paths, whereas the SOAP, I think your physicians are trained on all that intuitive assessments, right? That's how you would develop a plan, right? You would synthesize a plan from the information collected. It's a nice, I mean, SOAP, any of these tools I think it has a nice way of collecting information.
Well,
I
but
mean,
it also, you also have to, the data that you collect when you're doing a SOAP, it makes a difference. Is it from the veterinary technician? Is it from the doctor managing the case? Is it from the lab? You kind of have to validate the information, whether it's subjective or objective, and crank that into your thinking process.
Yep.
But all the time, I'm thinking about what's the physiologic normal and how does what is being revealed to me deviate from normal? And I think that thinking about economics, when I was reading through this paper and I was making notes on it, it was like, but they're not talking about what's normal for society. It's like, if you get enough people to say this is a new norm, then it makes it okay. And I would challenge that and say, I don't know that I agree with that, because you can have
Yeah.
whole societies that go down the toilet because of groupthink.
I mean, if you want a very formalized language, I mean, there are tools called SysML, which is an outgrowth, or it's a sort of superset of UML, and those are very formalized model language with a lot of different views of systems, and then, you know, tell you like timing relationships, you know, causal relationships, user roles. So those would be very prescriptive, right? And it's also, you know, the syntax is, again, it's formalized, so you can actually test it and things like that. I think that's too far to one way. The other one is organizing the perspective of a system, but then you do need a system has, if you think of like what, you know, definition of the systems, there are rules in that guide the interactions of the players or actors in the system to achieve some output or affect some output or some goals to it, you know. So that's the piece that's really important. I think, to find a tool that will allow you to sort of simply collect that relationship information. Causal loop diagrams themselves kind of do it, right? You can go into a causal loop diagram. It has a lot of, you know, you say, okay, what does a system look like? I'll just describe what touches what, and, you know, what are key parameters, and then you have to say, okay, where are the stocks in that system and stuff like that. That's, you know, from the CLD.
So Najla, you had a question?
Okay, go ahead.
Your hand up?
Yeah, I was just saying, like, I've never used Chat GPT, but back when I was experimenting with algorithms and like business systems, like I found the most that I find, you know, any kind of computer aided tool like that, and I would think AI is included. I mean, I actually did, if you count word clouds, which actually is kind of a form of AI, but you can actually get a lot of insights just out of word clouds, for example, and at least in business, that actually are valuable and actionable. And so just from that background, my perspective is that any kind of tool like this is going to be valuable if you keep in perspective what the tool is meant for, and it's not meant to, you know, and I don't think this is what you are implying in your presentation, but it's not meant to like replace human judgment in any way. It's simply meant to supplement sort of human creativity. And, you know, it's sort of something that you look at and go, you know, are there any interesting insights that we hadn't noticed before? And usually there are. You know, I mean, if the tool is advanced enough. So yeah, anyway, that's mostly what I had to say. And then I have a bunch of questions about your whole framing of this project, but we could save that for another time too.
Okay, so let me then pose this question. Again, doctoral students have to do a dissertation. Some people are beginning the journey. Some people are looking towards the end zone. With summarizing a large body of literature, right? Like Jack Homer, when he was doing his worker burnout model, he found that there was a worker burnout literature in management science, in psychology, and military science. And there was a lot. And it's like, how do you get a handle on all that? Do you think, and then there's meta-analyses of these sorts of topics. Do you think that a ChatGPT kind of tool could be used to speed up the process of getting a handle on all that information for the purposes of building a system dynamics model in an organized way, or building a social fabric matrix that can be then used? Do you think that's possible or worthwhile? Because again, that could be a dissertation paper for somebody. It almost doesn't matter what the particular topic is, but rather a way of combining AI with, well, the social fabric matrix and then with system dynamics. So we're kind of having a Venn diagram thing here with overlapping disciplines. What do you think? Yeah, Nashel, just whoever wants to chime in, sure.
So are you in this project sort of wanting, it sounds like anyway, and I don't know if I heard you wrong, that you're maybe wanting to combine these three methodological tools that are all from different schools in heterodox economics, and you've sort of analyzed like the advantages of each one to system dynamics.
Well, how you would use the various
combine them
matrices.
into one methodology, then that where maybe would have the advantages of all three schools in your view or something.
Well, I'm trying to get, there's a lot of, well, you took Steve Keen's course, right? So you should be seeing a lot of overlap between what he does and what we do. And he's a real economist. He's a post-Keynesian, right? But he uses his own package called Minsky. And one of the main features of Minsky that he believes makes it so superior to Stella, Venn, whatever, is that you can do godly tables. Well, I'm going to say, well, we can do godly tables, but also we can do SAMs, social accounting matrices, which are similar but different. And we can do the social fabric matrix thing and combine or make three different schools of thought comfortable with system dynamics, because we're integrating what they do with what we do. Now, that's what I'm doing as an econ guy.
You're customizing system dynamics for each school.
Yeah.
So that you have it kind of customized and ready. Mm-hmm.
Correct.
That's a
But
good idea.
what I'm posing here, because you're not economists, is I'm just saying this is the origin of how did I come to be doing this crazy stuff, is in whatever areas you guys are working in for your dissertations, do you think this could be, first of all, the social fabric matrix in general, and the other matrices we'll get to later in the course, could it be helpful to you? And then if it is there any value in looking or pursuing using AI to help somebody build a social fabric matrix and hence eventually build a better system dynamics model, because it can fan out and find lots of important stuff that maybe a human wouldn't necessarily think about, particularly if you're working alone. If you're working with, a whole team of really good experts and stakeholders, they might, you might get to where you want to be. I don't know the answer. I'm giving you food for thought for your dissertation research, right? And it might be this is a very bad idea and we should move on. I don't know.
I think there's some applicability to what I want to do. I had actually looked at something similar to this when I was trying to figure out my master's thesis topics. But one of the core problems in the Intel education career field and new like early career intelligence analysts that I found is that when you look at a problem set, say you're looking at North Korea, and you're like, what's North Korea going to do next? And you're trying to sort through all these things, and you're picking out certain events that are coming on that are happening, and you're trying to understand the importance of that event to what's going to happen next in the grand scheme of geopolitics. And it's a lot to sort through, especially when you are not an expert in North Korea, South Korea politics. You're new to the area. But you are surrounded by a lot of experts. So a lot of times analysts are thrown into positions where they're like, okay, you're now the expert. You're going to be briefing the generals and you got here 1 month ago. So you do talk to experts, but you have to figure out how to sort through all this data in your head to make recommendations and understand the situation full. So I think that having a mechanism to write down the key drivers of you know, a change in situation, you know, indicators, what would be an indicator of certain actions or things to come next could be very helpful. There is some things to that already, but it's not formalized. Like it's kind of an informal process that people go to. So I like the idea of formalizing it. We talked about it in the thesis or in our dissertation writing seminar, but I do think that it could have applicability from what I'm doing. Maybe
So,
not the AI. I'm not sure about the AI piece yet, but I have to look into that more.
yeah, so it's just, again, just seeding the field here. So one of the things I want to push in our research group and our complex systems lab is we build a good system dynamics model, however we do it. If we use the social fabric matrix, cool, or SOAP or whatever, the hexagon method, then we turn the model. Once we're convinced it tells us something useful and it conforms to best practices, it's technically correct, all that good stuff. Now we turn it into a game. And then we use the game with human subjects to see if people are learning whatever we want them to learn. And I think, like in the intelligence community, I got Ann Johnson, our recent PhD, to think about it this way, is to see if we're making people into better systems thinkers. So our model is leaders are systems thinkers, but also you could say military intelligence analysts should be systems thinkers, for example. They should be other things too, but having a systems thinking perspective, I think, is helpful. And that requires feedback loops, awareness of delays between cause and effect, and so forth. And so that's what, you know, it's not just the social fabric matrix helps us to organize variables, data, information, but it also helps us find the feedback loops, right? Which is a hallmark of systems thinking.
And to be honest with you, I think a lot of analysts are systems thinkers. They just don't call it that. But I think especially for new analysts, having a methodology where they have something we write down and kind of go through a process would help them develop that skill so that because they're thrown into it, you know, day one. So it was good to teach that, I think, in our initial training to develop it earlier.
Awesome. Okay. All right. So no need to belabor this, but I just wanted to, I kind of goofed around and I thought, oh, this is kind of interesting. I'll show it to the doctoral students. So let me ask one other question related.
Can I just say,
oh yeah, go ahead, Jim.
I was listening intently, but I was also testing out ChatGPT for the thing I'm working on. And it actually organized and provided me some information that would have taken me a little while to get. And it structured it like around the Orphan Drug Act of 1983 has an interesting effect on the development of medicines, the cost of the development, the reduction in the productivity of capital. In my opinion, I've always thought that based on the readings I've done, it actually was able to go and say yes. And this is why I gave a lot of really appropriate when I teach, I said, it's just drug regulations. Okay, well, tell me more about this one in particular. And it was able to do a nice job of adding additional text in it. But it was good too, because it's not just described in the regulations section. It said how would that affect the other parts of the matrix. Right. So it had the proper, it attempted to do the, sort of the causal cascades. So I thought that was interesting.
Yeah, good. So and I don't know how one would train ChatGPT if there's, because I know prompts are very important, and using the correct prompts to tell it what to do gets you better results. And I don't know if there's some kind of scripts you're supposed to be using or whatever.
I will ask an expert who's doing this as a business.
Okay, great. Yeah.
Maybe he'll come in and just talk with us because he's doing this for a living.
Because everybody wants to know, how does AI help me do whatever I do? Be a veterinarian, a military analyst, a pharmaceutical executive, a plastic recycling person, whatever, right? So, what I think we don't want to do in system dynamics is say the problem is reducing inflation in the US economy. We hit the go button and AI builds the system dynamics model, runs it, confirms it, builds a game, and spits it out. Because the human hasn't learned anything, right? Well, maybe you learn by playing the game, but you know, the struggle to understand the iterative process, remember the standard method, is where you learn. And that's what Jay hated about the concept of AI and its relationship to system dynamics. But if you say, look, we're still going to learn, we're still going to struggle, whatever, but we're going to use this tool effectively to just save time in certain areas. Like instead of reading 100 different annual reports from the pharmaceutical industry, because I'm building a big pharma model of some sort, I'm going to ask ChatGPT or Copilot or Bard or one of these things to go out and do that for me, but in a way that it brings back the sort of information I need to build a system dynamics model. So how do you train it to do that? And that's what I don't know how in the heck. I was just going, can you give me that? I have no idea, right? Maybe somebody's figured out, if not that specific example, but how to make it do stuff, train it a certain way. And Jim, yeah, if you could reach out and let us know, that'd be cool. So Nejla, yeah, what's up?
Yeah, I was just thinking, I think if anyone was going to use it in a, on a research topic, if you found that it produced some kind of promising, connection, obviously you can go and explore that further, on your own. You don't have to just rely on whatever it spits out, sort of. So, and yeah, I think it's definitely going to add value.
Okay.
And I just, so when we initially talked about the applications of AI in our first class, my thought is that more of the large language model data processes could be more useful for systems dynamics. Because like the last class, if we wanted to try to match data to our models, AI or large language models could take real-time data to kind of show performance against a model. So I think that there's some applicability to kind of maybe changing parameters in a model in real time to meet real world conditions as they're emerging. So if you wanted a model that kind of adapted to the current situation, I think my thought is AI could be applied there.
So somebody could end up being the world's authority on the application of AI to system dynamics in a manner that does not destroy the traditional system dynamics paradigm, but enhances it. And there's probably a whole variety of techniques that could be devised and written up in journal articles and what have you. I'm not suggesting anybody here should do that per se, but on the other hand, again, we're just seeding the field here, and we'll see what grows, right? In terms of cutting edge areas. All right, tell me a little bit about the hexagon method. Let's switch gears. So instead of doing a social fabric matrix, how about the hexagon method? You used to go to the SD conference, which, by the way, should have just wrapped up. What's today, Jim? Today's Thursday. I think they just wrapped up in Bergen today. I was Monday, I was on the past presidents meeting. All the past presidents of the System Dynamics Society meet once a year. And everybody's like, geez, you guys are looking old. Oh, and one sad note, Jim, you probably are the only one who knows. You know Andy Ford?
Yes.
So Andy apparently has dementia very seriously, and we all, the past presidents, Andy was a past president, we did a group like Get Well, Andy, all together on 3 kind of thing. But his wife said that apparently that sort of thing, he reacts to it. So that's very sad. So Andy was the father of environmental system dynamics, as a well-known book. Since Suzanne knows that. Yeah. So very sweet guy, very nice guy, very helpful guy, so very sad. And he's older than me, but he might be in his 70s, but at any rate, I just pass that along and wish him well. But the hexagon method. Okay, so how about, there's a short paper from the systems thinker on that thing. Fun with Post-it notes.
Yep.
Anybody, any thoughts on that, or anybody ever do that? Anybody ever participate in that, or?
I've done similar things.
I've
So-
done similar things in like architectural design sort of groups.
Okay, so if you're a system dynamics modeler, right, and you're
I
gonna
hate to-
help,
Can I interrupt for 1 second? So,
Yeah.
Suzanne, I did do it in SOAP also. It's interesting. So
Did you?
I'll play with it more.
so if if you're gonna be a PhD level system dynamics modeler, which means you've had more than one course. One course, you kind of are introduced to the field. Who was Jay Forrester? Who was Dennis Meadows? What is the national model? What was urban dynamics? What is Stella? You get all that, and you get the basic lay of the land, and the course ends. So you're by no means at that point a PhD level modeler, but if you want more, you're aware of it, and you know you'd like it, but you probably have to hire somebody at that point if you're not going to take any more system dynamics. But if you want more, well, here we are, right? Or you take college coursework. So as you become a more senior modeler, you're going to be asked to build models, to work with others to build models, including in a group setting with a group of experts and stakeholders. And you have to manage that process, or be in a team where you're off in a corner modeling and somebody else is facilitating, or work in the room, so to speak, right? And these are very different skills. And you might be able to do both at a high level or not, just depends on how you're wired and what interests you and what have you. But, the hexagon method is a way to extract the same sort of information that we're doing with a social fabric matrix or AI or whatever in an organized fashion. Now, a little less organized than the social fabric matrix. So can anybody describe how you do it? How do you use the hexagon method?
I mean, it sounds like you just write down like pieces of the system on a sticky note or a hexagon and then group them together into related pieces. And then you
Yeah,
have
that's
the
right.
different groups.
So unlike the two gyms, and I know there's really 4 gyms, Hakkenda, Thompson, Hines, and Linus. Hines was on the meeting, the past president's meeting. Jim Thompson's passed away. Jim Hockenda's here. I don't think Linus was there in the past president's meeting, but Jimmy Hines was there. So he was weighing in. He's a very funny guy. So he was cracking jokes. Anyway, Jim and Jim, Hines and Linus, in their standard method say, don't start with a problem statement, right? You read those papers? I disagree with that. Or they're not wrong. I don't like to do that. I like to start with a problem statement. I always say in a consulting engagement, typically, why am I, I'm Mike, it's like, why am I here? Tell me what the problem is. And that it can go rather quickly. Everybody in the room knows what the problem is. No problem, no pun intended. Or it takes 2 days of wrangling for everybody to agree, reach a consensus on, just exactly what's the problem here. But the way I use the hexagon method, I get a problem statement, and then I say to the room, tell me the variables, the factors that impact or cause or relate to this problem. Put one variable, one factor on a Post-it note or a hexagon, Post-it note or a traditional square one, doesn't matter, and go stick it on the wall. Usually like a big whiteboard, right? So, by the way, sidebar, if you're going to be brought in to do this sort of thing, and you're going to have a big room of people who know a lot about whatever, right? Make sure you ask for a room that has a giant, like whiteboard. What you don't want to be in is a mahogany paneled walled room where if you put a sticky note on the wall, somebody loses their mind because it's, Italian mahogany or whatever from Europe. Whiteboards work the best because you put them in. So, and then say, everybody look on your desk. Here's a table of Post-it notes or a stack of these things. One variable on each thing, write one down and go stick it on the wall. And so and then talk to your people at your table. People enjoy this. right? Now, if it's a hexagon, it's easy to connect the shapes, right? And then you kind of see it's petering out. You're watching the room. Okay. Then you say, all right, go up there and put in piles or right near one another. Or if it's the case of the hexagon, put two edges together, of variables that are similar, right? So if you remember from the first course, we had the heroin crime example, right? And, like put all the police stuff in one pile and all the addict stuff in another pile and all the drug dealer stuff in another pile and, whatever. And what happens is you naturally start to see the sectors emerge, a pile here, and those end up being the sectors of your model typically. And then with the hexagon method, instead of kind of just all, sticking them up there in some random fashion, you say, make sure you put the edges together, and there's like you start to see causal relationships. Or you can say, now go up there and put the edges together when A causes a change in B. A change in A causes a change in B. Put those sides together. And you can begin to kind of see feedback loops emerge and sectors and what have you. And what's funny is when you say, is everybody okay with that? Now go up. First you say, you can change your mind and move your sticker, but you can't move anybody else's. Then you say, go up there now, and if you disagree, move somebody else's sticker. And that's really funny. They go up there, everybody's switching stuff all around. You're, hey, don't touch my variable, but it's consensus building. So you say, all right, what does anybody object to something? Yeah, Fred moved my, whatever. Say, Fred, why did you do that? Well, because I thought this. And you say, Sally, what do you think? Does that make any sense or what? So you start to get a consensus or you say, all right, disagreement can't be resolved. Let's keep that in our hip pocket, right? Because, so it's an interesting process. There's no one theoretical way to do it properly. It's as much as an art as it is a science, I guess. But system dynamicists do that. Usually in a group model building session, usually when there's a bigger group, not like 4 experts or 6 experts in a conference room somewhere. It's usually when you've got a bigger audience and you want to get them involved in the modeling process rather than they don't want to sit there like they're watching a movie and watch the movie star Mike build a model. Boring. They want to feel it's their model that they helped to build. But they don't know how to build it. That's why they've hired you to do it or brought you in for whatever reason, but they want to contribute. So when you've got a larger audience, the hexagon method I found can work well, and you don't have to go and buy the hexagon Post-it notes, just use regular Post-it notes. I don't know that there's much of a difference. What Sturman will say, and he would say it repeatedly, was, well, you could take butcher paper and make, let's say, a beer game board and hand draw it. But he goes, if you're a professional consultant getting paid, buy the damn vinyl board. It looks more professional. Similarly, you can just use any old Post-it note, but really, if you want to look pro when you go into a consulting engagement, the hexagons are nice, So it kind of depends on, it's sort of a visual cue, even if it doesn't get you to a different place, you kind of get the same result. So anyway, yes, Najla.
What I like about the hexagon approach is that it's more vague than the social fabric matrix, which makes it a lower stakes kind of activity for a group of stakeholders who may have extremely divergent views or interests in the project, where you are trying to kind of just avoid conflict at any cost in the first couple of rounds. You know what I mean? Where the stakeholders may have already had past like conflicts, and just starting at the social fabric matrix could just break out in and no, we're done. Forget this.
Okay, and you got to know your
That's what I
room.
like about it is that like literally just having sides touch, like that is so vague, that is so low stakes. You're not saying anything. They just have touching sides. Like that's it. There's not even an arrow pointing up direction. It's just very, you know what I mean? So I can see the value depending on who your stakeholders are choosing.
Yeah,
the
if they, you
genre.
got people who really disagree with one another, then yeah, you gotta adjust and make sure that whatever you're doing is not inflammatory, because hey, we're trying to build a model together and work together, reach a consensus, not inflame
Right.
people and whatever.
Yeah.
So is it possible to use the hexagon method with the social fabric matrix, do you think?
Yeah, I would use the hexagon method first for sure, because I do find it more vague. And then sort of once you got that, then you can go to the next stage and people will be less likely to be like, what do you mean this affects that? You know, so yeah.
Okay,
Yeah,
so
I,
yeah,
I
think,
agree with
go ahead.
Oh, I agree with Najla. I feel like hexagon method's like a good brainstorming, like let's just kind of get ideas stuck on a board and then yeah, go to the more specifics.
Yep, yep, Suzanne, yeah.
So I have to kind of go back a few steps. I think this is a very worthwhile discussion, but you know, the thing I noticed in the social fabric matrix and the problem with thinking about facilitating a group this way is you have somebody in the group saying, this is the problem. Like Ashley, for example, saying in this particular part of the world, right now, we see this activity that's causing us great concern. Okay. And we perceive this as a problem and we need to do more surveillance. We need to understand this better. And in medicine, and I'm in my head going, I think this same thought applies to any other domain. Like you would have to start from the position of what is normal for that environment. So that when you're trying to discover the nature of the problem and flesh that out so you can do an SD diagram, there's value in saying what is normal and what is here that is not normal and what is missing that should be here. That is a super important part of the process, whether it's one individual being or whether it's an economy or whether it's a social phenomenon, or whether it's a safety risk from an intelligence perspective. I mean, I think I would be really curious to try and like use the SOAP method with Ashley telling me about how they work through these intelligence investigations, because I think that probably can fit into a SOAP method. Just because if we're modeling something that has some valid basis in natural existence, then I think we're probably on the right track. I don't know who said that, it wasn't me, but there's some validity to that. And the fundamental, when you're dealing with a problem, what makes you think this is a problem? What is normal? I think we've completely skipped that step, and I think it's really important when we're trying to build a model.
Yeah, like I said previously, sometimes in my experience, the problem is obvious and everybody in the room knows it and they tell you in the first 5 seconds and there you go. And other times it's 2 days worth of sessions to get everybody to agree on, do we even have a problem? What is it? So on and so forth. So yeah. So I guess I would say one thing is becoming clear to me, but hopefully to you, is that there's a bunch of different tools here that we can use, and we might use different tools in different circumstances to get the conceptualization process underway. It's not just one way. If the only tool you have is a hammer, every problem is a nail, you know, that kind of thing, that we should think about having a toolkit of different techniques that we can use depending on circumstances, at least in the conceptualization stage. Yeah, Ennis.
So mine is more so a question. From reading the paper, I realized they mentioned that you can summarize the responses that you get from the participants in the room into 3 or 6 words on a hexagon, and so it's making me think or wonder if it's possible, like you mentioned, if we can use the social fabric matrix, like the themes in the social fabric matrix, like the socio-techno stuff, you can use those instead as the overarching themes, and then use that to solicit for some type of information from the people, and then group that into the model that you want to
Yeah,
make.
you could have different colors of the Post-it notes or the hexagons for the environment and the economy and the culture and whatever, I suppose. Sure. So that's clever. And I'm not sure anybody's done that or not, what you've just suggested. Just because I don't know if somebody's, that doesn't mean it hasn't been. Somebody might be doing it routinely, but that again would be something that would be quite interesting for a doctoral dissertation if you needed to collect information from experts and stakeholders about something, right? Plastic recycling or whatever. And you said, you know, just letting people take Post-it notes and go wild is a little too unstructured, but maybe the social fabric matrix is too structured. A happy medium would be, let's use hexagons, but colored, and the colors are kind of representing sectors that we're deriving from the social fabric matrix, but we're not showing anybody that yet, or something like that. Yeah, that's clever. That's cool. So there's no theorem that says here's the only way to do it, right? It's, you know, different people have different ways, and we need to experiment, right, and find what works for us, and then what works as a general proposition where we can teach it and repeat it and what have you. Okay. All right. Any other things on this topic? Or, I mean, we kind of get it, I think, right? Is there's a.
I think that I think your idea, Mike, of assembling a toolbox is a very valuable concept, because you know, to me, that's like, what are the tools for evaluating the data that we're producing in any kind of collaborative model building or assessing as a problem or not? And depending on the sector, those tools might be different. And I think there's a lot of value in doing that as part of system dynamics and identifying kind of best practices. Well, when we're dealing with economics, these are the tools that we use because they've been proven to be reliable for these reasons. Or if we're doing intelligence for the armed forces or whatever, under these circumstances, these are the tools that we use, and this is how you implement them into system dynamics. I think that could be very valuable.
Yep. Yeah, getting to people to think about a toolkit rather than one tool. And we use the standard method. So yeah, so
Well,
we got to broaden our thinking.
Yeah, you know, I mean, because it's just like, you don't want to use an ultrasound on a broken leg. That's not the right tool for diagnosing an ultrasound. You use radiography. I'm just saying, in different domains, they know how to get the information they need in order to go to the next step, which is to develop an intervention of some kind. And I think each domain in which system dynamics deals with complexity probably has an identifiable toolkit for coming up with data that's valid to then put into a system dynamics diagram. I haven't seen anything like that.
Yeah, I mean, Sturman wrote a paper a couple of years ago about system dynamics at 60 years old. And he talked about all the different tools and techniques from anthropology and what have you, that there's no reason not for us not to utilize them, to learn them and utilize them. When you talk to people, just don't go in there and talk to them. There should be some organized scientific way that, let's say, anthropologists have learned to talk to people in a scientifically valid way to try and minimize biases and whatever, blah, 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 all that stuff. So toolkits, thumbs up. All right, good. In the interest of keep her moving, as we'd say back in Wisconsin, let's keep her moving. Let me see what else I got up my sleeve for tonight. So, all right, so our dynamic syllabus here. So we talked about reference modes, a little bit of problem statement that we turn into a reference mode. We did a lot about that stuff in the first course, right? In this course, we talked about more another topic in the area, which is if you have real numerical data, we might want to think about slicing the problem. And in the example I showed you, detrending of the data, right? And I showed you a technique for doing that, but even still, it wasn't obvious what was the reference mode. We really had three possible reference modes. We had the trend, we had a longer cycle and a shorter cycle that came from the data, right? So in economics, it's known as, well, the trend is the trend, and the cycles are known as more of a Kuznets cycle and then the business cycle. I think the economists have identified different cycles in the data, but like Khaled would say, don't try and build a model that has explains all of that in one cut. Pick one and start there, slice the problem. So we discussed that. And I also mentioned the optimal shape parameter, where visually, when you want to understand some data, the aspect ratio of the graph matters, right? And there's an optimal way to do that. And I was sad that none of the software creators in System Dynamics ever picked up on that. They're always kind of like, yeah, whatever. But
Well,
I
that's a
I
tool
hold
in
out hope.
Stella. That's a tool in Stella, isn't it? That's one that we've used before.
No, the optimal shape parameter, it would conceptually be a button you could, after you do whatever graph, you'd grab the Bezier handles and resize it however you wanted, and then you'd click presumably a button, and it would redo the aspect ratio so that along the formulas in my paper, so it would optimally present the time shapes for you. And that's
Because,
never been
like-
done in the software.
Like Ashley showed me in Stella how to just click a button, like click a box to allow it to have multiple X and Y axes so that you can see like different ratios, aspect ratios in one graph.
Well,
but
Yeah, so yes, our graphical tools have gotten a lot better over the years, but no one has ever done this particular optimal shape thing. And I mean, my life doesn't depend on it, so whatever. But I hold out hope that someday somebody will think that's a good option to add to the software, but it's not that big a deal. Anyway, my point is I'm just summarizing what we've already discussed, right? So where does that take us? Well, we got a couple of important topics here that we want to talk about, and one is tiles inequality statistics. Okay, so what is that all about? So, oh my goodness, there's that. And I don't know if I put John's paper up here. Anyway, so when John Sturman was doing his doctoral dissertation, his dissertation was 4 volumes long. It's the most massive dissertation. It's about this thick width because it's 4 large volumes. But he built a macroeconomic model that looked at the interaction of the economy and the energy sector and the feedbacks among them. And he looked at energy policy. Now, he was doing this in the late 1970s when there was the OPEC oil embargoes. So energy was a big deal. Energy issues was a big deal. So at that time, he got his model to fit real time series data from the economy. Okay, similar, I showed you the GDP data and I detrended it and all that. Well, data like that. And I think he as I remember, he manually fit the model to the data. There was no algorithm at that time in the software that could find and grind and fit the model tightly to the data. So it was, as I remember, I haven't read it in a long time, but I think that's what he did. At any rate, the question becomes, how well does the base run of your model in System Dynamics fit the reference mode, right? So let's review. We start with a problem statement, right? And we turn the problem statement into a picture called the reference mode, right? And the reference mode is a graph or graphs of 1 or 2 or 9, however many, a modest number of time shapes, right? That shows you a visual picture of the problem. Something bad is growing, and you see the red line is growing and growing exponentially, or the economy is going up and down. We'd like it stable, or whatever, right? So the base run of a System Dynamics model should mimic or look like the reference mode, the problem, right? Because the reference mode is a dynamic picture of the problem. And if it does that, then we say the model offers an explanation for why the problem is occurring. right? Now you get into a sidebar here. It's like, okay, more specifically, why is I get it. The model and the real data look the same. So the model is explaining the problematic data, the problem. So what's the explanation? Why is this happening? Well, the complex model, it's not necessarily obvious. So we need tools like loops that matter to help us. So we'll talk about that later in the course. But for now, that's the idea. We have a problem statement in words, and we might extract it from a group of experts and stakeholders, or we might be doing it on our own. It doesn't matter. And if you remember our doctoral seminar stuff, right, we're always asking in paper number 1, what's the problem? What question are you going to ask and answer, right? So there's a problem statement. We make it into a dynamic picture called a reference mode. So it's a graph or graphs of variables over time. They're time shapes. And of course, that requires us to specify, well, what do we mean by time? Quarters, months, weeks, years, whatever, right? And we not only look at the time shapes in isolation, oh, it's oscillating, oh, it's growing or whatever, but we also want to look at the time shapes in relation to one another. This going up makes this other thing go up. When this thing goes down after a lag of 2 years, this other thing goes down or whatever the case may be, right? So we want to look at the time shapes over whatever we mean by time, whatever length of time, so many weeks, so many years, so many minutes, whatever, and the important variables that are part of the problem statement. What are their time shapes and how do they behave in relation to one another, right? So let's hit the brakes right now. Everybody remembers that or knows that or gets that, or is that unclear? So we're modeling a problem from a systems perspective. We're not modeling the system, right? No issues there. Everybody gets that? Okay, thumbs up. Good. So then we build the model.
But Mike, I was going to just offer up. I mean, the thing you're observing is produced by the system, so you do have to have structure that represents the system.
Yeah, we haven't gotten that far, but yes. But the reference mode is just the system is behaving in a way.
Yeah. The system's a black box, and it something is happening going into the system, and something's coming out on the other side. There's a transfer.
So the airplane isn't flying is the way we want it to. We want it to fly higher, faster, more fuel efficiently, carry more cargo, not bouncing up and down, whatever the friggin' problem is. We want to understand why is it flying improperly, and then later on, what policies, what do we do to redesign the plane so it behaves better? Whatever better means, we have to define what better is, right? So everybody gets that. That's and again, the two gems say don't start there with a problem statement, but I like to start. Okay, so once you have a model, it doesn't have to be completely finished, but where it's working and you start to say, yeah, I think it's, we got something here. The obvious intuitive thing you'd like to test is to see whether or not the synthetic data being generated by the model looks like or mimics or fits the real data, right? Now, if the reference mode is qualitative, which by the way is perfectly fine, and let's say drawn by hand by a couple of experts, that's perfectly fine. They'll say, look, I don't have data on my company's morale, but I can tell you certain times of the year we're high as a kite, and other times where nobody's wants to be here, is angry, mad, depressed. Then we're high as a kite again. Everybody's thrilled to be here. Then we go down. We need that smoothed out. And you say, show me your morale data set in Excel. And they're like, well, we don't have something like that, but I've done this for 20 years. I can tell you that's what it does. Every year in the spring, it's here. In the fall, it's here, whatever, right? They can tell you that. So qualitative is okay. But usually if it's qualitative data, hand-drawn, let's say by experts, your model, you're not going to take the time typically to fit the model to their hand drawing. You don't even have numbers to fit it to. Now you could try to estimate some numbers or whatever, but that's usually not done. But if you have real time series numerical data, like I showed you, like the GNP data or GDP data, excuse me, right? Now you can fit the model to the data, right? Did I go through the saga of how we arrived at fitting models to data? Oh, I think I did with Dave Peterson, right? The Schweppe equations and all that stuff, right? Okay. So Forrester never bothered to fit his models to numerical data. Khaled Said doesn't think it's a good idea either, waste of time. Most system dynamicists who are good and know how to do good system dynamics modeling will say, I think it's important to fit your models to data, to numerical data, but it's a very weak test of how good your model is, how valid your model is. Because every sort of mathematician will tell you, they'll know that a sufficiently complex polynomial can be fit to any data set to any degree of fidelity you want. It won't tell you anything. Like who cares, but you can twist it and turn it and with enough degrees of freedom make it fit some data set really tightly, but it can't forecast or predict or anything like that. So in other words, because the real data is my red curve and it's doing whatever it's doing, and you say, oh, look, my model, the blue curve looks just like the red curve, I fit it to it and they look pretty close. Okay, that's not a powerful test in terms of overall, how good is my model? Should I believe my model? But here's the key. People, particularly non-modelers, expect to see that. If you are working with, well, they don't even have to be clients, experts and stakeholders, just, in economics. I have a macro model. Every economist is going to go, well, how well does it fit the country's GDP data? Right? They're going to intuitively say that. They're going to want to see that. And if your model can't fit the data, now that tells you something. If you use the Schweppe equations and Powell algorithms and all that stuff, and you torture the model and it cannot fit the data, that tells you something. Your model's just wrong. Going the other way, or not quite there yet, but going the other way, if you let the algorithm grind and find, and it fits the model very tightly, that's good, but it doesn't really tell you if it's a good model or not. But your client is going to want to see that. The general public is going to want to see that. The politicians are going to want to see that, right? And if your model can't do that, they're going to go, oh, well, it's not a good model, right? So it's when the non-modelers, people who don't know about modeling, but can make decisions, when they're in charge, they want to see the frickin' two curves look like one another. Okay? So the reference mode and the base run of the model should look alike. The model's base run should be fit to the data if you have the data. Yes, we all agree on that. So Najla, go ahead.
Oh, yeah, I was just a little confused on your, the part about how fitting the model to data isn't necessarily a good, like, scientific test of the model, because I'm just confused if you're talking about that's if you only have like one data set or a data set from one time period, then of course, yeah, you can make, you can create a complex equation to fit it that doesn't necessarily, that isn't ergodic or doesn't predict the future. But are you saying that also holds if your model continues to predict future data sets consistently, that it's also not a good scientific test?
Well, yeah.
Or are you more making a point about
what you do is you hold back some of the data set and you fit the model to the first part, and then you see if
Right,
it can.
That's what we did when I did business analytics.
Yeah, that's standard sort of econometric time series analysis or whatever. And that's fine, but you have to recognize when I would do data science stuff, I would show two different neural nets that I built. And one was fit pretty well to the data, and the other one was fit where you couldn't even tell the difference between the real data and the synthetic data, the neural net. And the first one that was kind of well fit could predict the unemployment rate several periods in advance pretty well, holding back the data and all that stuff. The really tightly fit one couldn't forecast to save its life because
I mean, that's
because
my point though. So if it's forecasting, doesn't it sort of overcome that limitation if it does forecast future data?
what I'm saying is the model that wasn't as well fit forecast better than the one that was very tightly fit to the data, where you almost
Right,
couldn't
yeah.
tell the difference.
I
So
understand. I see
because
that.
you tightly fit a model to data, and we have very powerful algorithms these days that can do that, doesn't necessarily mean it's a good model. But if you apply these powerful algorithms to a data set and it can't fit the model, where you're like, the green curve just doesn't look like the red curve no matter what I do, that tells you something. Okay. In my case of these neural nets, the one that was really tightly fit was horrible. I wouldn't use it. It was for trying to forecast the unemployment rate for trading the financial markets, but you'd be crazy to use it. Because but the two curves, if you showed it to a client, look at my neural net at first, So because what was going on is you want to find the trend, not the
I'm
noise.
familiar.
And it was
I know
fitting,
exactly
it was
what you're
fitting to the
talking about.
noise as well as the trend. Because there were too many, you didn't have enough degrees of freedom. You had too many knobs, too many parameters that could be tweaked. So you could twist the thing, the algorithm could twist it and turn it every which way. And so there are ways to fight that in data science and whatever. But again, in system dynamics, we're not trying to predict a number 2 periods out. We're trying to redesign the airplane so it flies better. So it's a very different thing. Okay, so generally speaking, even though Jay said we didn't need to do it, if we have numerical data that we use for a reference mode, we want to fit the model to the reference mode. So the synthetic data and the real data look very similar, or as similar as possible. Okay, so it builds confidence with the client. Okay, although it doesn't tell you it's a great model just because it can do that. It tells you it's a bad model if it can't do it, if you're following the chain of logic. Okay, so back to John Sterman. He's making this large macro model, and I think he's manually fitting it, as I remember the story. And so it was, the real data was doing this, and it was sort of similar. And the question is, well, okay, I get it. If the blue curve and the red curve are almost on top of one another at all times, it's a good fit. Duh. But what if it's kind of, sort of a good fit, but not perfect, or not really, 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 really close? What do you do? Well, here's what you do. You use Theil's inequality statistics. Okay, they were created by Henri Theil, who was an econometrician. And the story is that when he was a professor at the University of Chicago's econ department, he was really top notch. And then he semi-retired and went to the University of Florida because the weather was nicer. And he was no longer interested in teaching. So he would take out his econometrics textbook and read it to the class. All math. And then the students would all drop, and he'd be like, everybody dropped the course, so I don't have to teach. I don't know if that's true. That's the lore that used to, when I was a student of economics. But Henri Theil's text, I don't know if I have his textbooks here, but anyway, it's really good stuff. So he came up with Theil's inequality statistics, and John Sterman wrote a paper based on his dissertation that this is the thing you should be using in system dynamics to see if your model fits the data, your data set very well. So here's the paper, John's paper. Okay, and so back then he was an assistant professor. Now he's the J. Forrester Endowed Chaired Professor, right? And he writes oh, by the way, just so everybody knows, Dynamica was the journal that preceded the System Dynamics Review as the official journal of System Dynamics. So when we created the System Dynamics Society in 1983, I was there. I was only 3 years old. We created it in 1983. One of the many discussions was, would Dynamica morph into the official journal of the System Dynamics Society, or should we start a brand new fresh journal? Now, the politics behind that, there's always politics, was this Dynamica here, which at the time was the only journal of System Dynamics, was published in the UK. So the Brits and the European folk advocated making this the official journal. Did they win? No, because the official journal is the System Dynamics Review. We created a new journal from scratch. Now, I was a student, so I was not involved in those deliberations, but there was a whole lot of huffing and puffing about how the society should be an international society, not an MIT society. And so the non-Americans, non-MIT people were like adamant about that. And there was a whole lot of arm wrestling about the journal and whatever. But this preceded the System Dynamics Review until 85, I think, until 1985. This was the journal for system dynamics in the world. So Sterman puts in a paper and he's explaining all the tests of model validity here. And then he's talking about, well, you got to fit your model to data. And he says, this is the appropriate statistical technique. And he's going through the standard presentation of this stuff, blah, blah, blah. And then he gives some examples here as to when you compute these three. So Tiles inequality statistics has three components, okay? And the amount of variability in each of these components tells you about the fit of your model to the real data, okay? And then he's going through his, the energy import and all this. This is from his dissertation in the paper. So you can see here's from his dissertation. You can see the simulated and actual. So it's not an exact fit of the two. It's a kind of sort of fit. You know, here's his model. And then the actual, well, you get the idea. It's not perfect. Well, you know, again, simulated and actually is kind of getting the trend, not the cycle, but you got a downturn here. So how good is the fit? Right? Well, Tiles inequality statistics are what you're supposed to use until somebody comes up with something better, I guess. That's what we use in system dynamics. So this paper is over here, right? You can read it if you want. Now, I took it and John skipped all the steps. So I said, he goes, this can be made into this, is equivalent to this. And so I said, let's find all the steps so my students can follow along at home. Now, I used to do a lot of econometrics and statistics when I was a young pup. So this was kind of what we did when we were doing papers like this. So my dissertation director was an econometrician, so he had me doing all this stuff till I wanted to scream. So I'm not very adept at it anymore, but 40 years ago, I was pretty good at it. Anyway, so let's see if we can follow along and see the mindset of Henri Tile, or how you would goof around with this stuff. So you start out with a proposition here that the mean square error, okay, can be, which is this definition here, can be broken into these three terms. So there's three terms, okay? And then we're going to divide each term through, you'll see as we go along, and you'll get that UC, and I can't remember what the other U is, but the three components of Tiles inequality statistics that you can use to determine the nature of your fit of your system dynamics model to real data. Okay, so what is mean square error over here? So this jagged thing is a summation sign, right? It means add up. So what you're taking is the simulated data point and the actual data point for time period T. So if it's annual data for from 1980 to 1990, it would be the annual data for 1980, and what the simulation model said that equivalent variable was in the simulated year 1980, and then for 81, and so forth going along. You subtract one from the other, right? If ST minus AT is 0, it means the model and the actual data point are identical. Yes? But they're almost never identical, right? They're hopefully close, but not identical. And notice, if S is bigger than A, your model is above the actual data point, the difference will be a positive number. And if it's the other way around, if A is bigger than S, your model was below the actual data point, it's going to be a negative value. And if you, when you sum up, you're adding up all the misses between your model and the real data point. But when you got positive and negative misses, they will cancel each other out, right? A minus 1.5 cancels out half of a 3-point miss, right? So what do? Well, you could take an absolute value here, but as soon as you do that, it makes it mathematically more difficult to manipulate. So the standard procedure in statistics, traditional statistics, is to square the miss. So you get rid of the positive and negative thing, and you also have the added benefit that you punish really big misses because you're squaring the miss. So the bigger the miss, you square it, you get a more punishment. Your mean square error looks bigger, you want it small. Small is good. Okay, everybody following so far? I mean, this is not that hard, but just making sure not everybody has a different sort of math background. Okay, so then what you're going to do is you're going to look at every actual data point versus the simulated data point for the same time period. Take the difference and square it. Then you want to know what is the average or typical squared miss of my model from the data. So on average or typically, how much am I missing squared? Okay, that's what that's saying. And again, I'm hoping, tell me if you're not, when you're not catching what I'm saying, tell me. Otherwise, I'll assume you know you're following, okay? And that's a very common, they call that technically in econometrics a quadratic loss function. Quadratic because we're squaring, loss because we're missing, okay? All right, so the proposition is that this is the definition of mean square error. We can break it into this over here and then divide everything through to get this tile stats. So I'll show you. So let's go through and, just real quickly, we don't have to dwell on this, but you should be able to follow along. So what you're inclined to do, you see a square is expanded. So it's ST times ST is ST squared, ST times AT, and AT times ST is 2 STAT, but there's a minus sign in there and an AT squared. So we just expand it. The summation sign and 1 over n are linear operators. You leave them alone. They don't futz with anything. So this is just, you did this in 8th grade probably, right? That's this. The key is recognizing that this is this over here, right? Because you got this sigma in there and whatever. Then guess what? Because this is a linear operator, these are linear operators that can go inside the parentheses here. A constant is also a linear operator, so it gets out of your hair. So we're just going to bring this through. It's going to hit here. It's going to hit here and so forth. And 2 gets out of the way. So we just brought 1 over n through here. So we're distributing it. Okay. And then this is where you get into a lot of this treachery with proofs. This is very common. You say, look, I have to build this over here. I'm trying to show this. I have to build that. So let's put in, I need an S bar. I need an A bar. That's the mean. The average simulated data point and the average actual data point. So let's put the sum of these two guys in here. Admittedly, they're squared, but again, you're thinking ahead. but if you add it, you got to subtract it. So as long as if you're going to add it in, subtract it out. And look at over here. This is another trick. N over N. See, I'm minusing. There's a plus sign here, plus S bar squared minus S bar squared, but I put N over N. So the N's aren't really there, but I needed to build this thing, right? Okay, same thing over here. So this is treachery, mathematical treachery. Okay. Then over here, we're just collecting terms. That just comes down. My cursor keeps disappearing on me here. This thing over here just comes down. So I note that, why am I doing it this way? I want to build this and I want to build this. So why am I building that? That's the definition of the variance, the sample variance of the simulated data and the sample variance of the actual data. Okay, so how did I know I wanted to stick this stuff in here? I'm trying to build this. Okay, and that comes down. And this last term here with the 2 in it comes down. Okay, because remember, up here, I'm trying to build this. Right, there are my S's over there. Those are standard deviations. I got variances here, but I'm hot on the trail. Okay, so again, another trick. Add and subtract 2 S bar A bar. So I subtract it there. I add it over here, and there's the N over N trick again. Okay, again, I'm trying to build my answer. Okay. And then let's see, what did I do over here? Oh, I note that, again, this is like A minus B, the quantity squared, you expand it. So now I contract it. I note that this is equal to S bar minus A bar, the quantity squared. The rest of the stuff just comes down. Now I'm going to add and subtract 2 times the product of the 2 sample standard deviations. Here I'm subtracting it. Over here I'm adding it. Okay. And when I do that, what did I do here? Oh, in order to do that, that comes down here. And when I did this over here, I'm trying to remember what I did. Oh, this guy just comes in here. And then I pull the 2 out of there. So I got a 2, a 2, and a 2. And I can yank that out of there. Okay, get it out of my hair. Again, we're gonna note that this can be collapsed to this, like A minus B, the quantity squared again. And over here, I note I have common denominator there, N. So we can combine these 2 terms into this over here. And then I notice that this is the definition of covariance. Covariance is the same thing as correlation, but it's not normalized. Okay, so think of a correlation between 2 things. It's dimensionless. It doesn't matter what your units of measurement are, inches, feet, pounds, or whatever. Covariance, it makes a difference. You'll get a different, if you want to know, if the length of baseball bats and the temperature outside in Fahrenheit are correlated, okay, you can run a correlation coefficient. It doesn't matter that you're correlating degrees Fahrenheit and inches, but it does matter for covariance because the units matter. If you are measuring in millimeters instead of inches, you get a different covariance for the exact same baseball bats and temperature. So covariance is like correlation. It's just not normalized to take the units of measurement out. And by definition, it's this. You'd have to take a stats course to know that. But you recognize that's covariance. The rest of the stuff comes down. And then you can say, I'm going to pull, excuse me, what did I do here? Squared 2, trying to remember, this comes over here. So, so then knowing what the definition of this is correlation, remember covariance is like correlation, it's not normalized. So this is correlation, which is the covariance here. See the covariance normalized to take the units of measurement out. And so you just fiddle with that. And you note that S, these 2 guys are this, and R is this. Okay. And let's see, that is, okay, that cancels out here. And that's where you get to the correlation coefficient there. That I skipped a couple steps there, but that's okay, I guess. This is in the Sturman's paper, but this is not part of the proof. So we skip down here. And so now we decompose 100% of the mean square error the average squared distance, our actual and our simulated data miss, into three components here. Okay, that's so we divide everything through by the mean square error. Okay, and so these three components are all of the mean square error broken into their components. So the one over here, this is the fraction of the miss between your simulated and actual data due to bias. Okay, and so it's the average missing of the two data series. This is the fraction of the error due to unequal variances. That's a difference in the match of the trends. And this is the fraction of the error due to unequal covariance, point-by-point match of the series. And that's, UM, UC, US, according to Tile. And so what John shows you here is if all of the value is like 100% is here, and this is 0 and this is 0, then that's what your actual and simulated would look like. Okay, that's due to bias. Okay, so that's the average miss of the two series. They're the same. They're always, you got railroad tracks. If everything is loaded into the second term, okay, this is the systematic error over here due to unequal variance. The trends are wrong. You got two trends going like this. With A, you got the right trends, but they're biased. With B, you got the wrong trends. And with C, I shouldn't say B, but M and US, but with UC, the last one here, different phasing. Okay, so that's over here. The point-by-point match is off. You got the trends nailed, and they're unbiased, but the point-by-point match is off. Okay, so this is kind of the gold standard. So if you had real time series data for your reference mode, and you built an SD model that mimicked the reference mode, mimicked the data, therefore explained it. Doesn't mean it's the explanation. Your model would offer an explanation for why the problem is occurring. And then you try and test policies, redesigning the airplane so that it flies better. So you make the reference mode less bad. You give that paper to John Sturman. You give that paper to Jack Homer, okay, and other such system dynamicists. They will reject it unless they see you fit it to the data and give them Tile's inequality statistics. Or they might not reject it. They'll say, redo it, revise and resubmit your paper, because we want to see Tile's inequality statistics. How good is your fit to the data? Okay. Here's how you do Tile's inequality statistics in Stella. Okay, so there's a bunch of goofing around here that we don't have time to get into every detail here. But in this case, you want to know when the simulation is done. Where are we at? And you can see we have bias, variation, and covariation, the three components. And you have 99.8% is due to covariation, this right here. So I had historical data and real data, simulated data and real data, historical data, but I made them up just to show. So this thing, you should get everything over in the third component, which is this one here, right? And it's in, this one here in the third component, right? That's the same thing, right? So it works. All right, let's tap the brakes for just a moment and see if we followed all that crazy. Like, why are we doing it? Then there's the details. And then we have a software solution that we can just pop right in to our model.
That's when you send brownies with nuts to your buddy that does statistics before you give your paper to John Stearman, so he doesn't embarrass you in front of everybody at the group meeting.
Okay. Embarrassment can be a great motivator, but it usually has
Not by him.
consequences.
Not by him. But
Well,
I mean,
John's
I understand the whole idea is in order to really assess whether you have a good grasp on the problem and you have defined the problem correctly, you can test it, your reference mode with this statistical process. I mean, that makes sense to me. I would hire somebody to do it for me, but I understand why you want to do that, because if you haven't clearly defined accurately your problem and you go to the process of doing a causal loop diagram and building a simulation model and your problem basis, your problem statement is not correct, you've just gone on a wild goose chase. I understand.
So again, so the kind of thing that, going back to John's original paper and his dissertation work, you know, we zoom down here and it's like, is that a good fit to the data? Is that a good fit to the data? Is that a good fit to the data? Well, it depends, right? I mean, it's like, so what John is saying is like, look, econometricians, statisticians have a way of evaluating, you know, so the root mean squared error, by the way, I skipped over it. I said it's not part of the proof. That gives you an absolute value. The lower that number is, the better. And then this tells you why, if your root mean squared error isn't 0. 0 would mean it's perfect match. If it's not 0, why is it not 0? And you can decompose the why. And then from all that information, you can decide whether or not you're happy with the fit of your model to the data. You know, if you're biased, you got to just, you can close
Mike, can you go back to figure 3, back up. 3A, the energy input. So so that fit is better at, you know, if you started at 1960, I guess, right? Is a reasonable fit, but before 60 is not a reasonable fit. Does that suggest the model's missing some structure?
Could be. Then you say, well, but
Or maybe
that's pretty good.
maybe some of the initial
Over here,
maybe some of the initial conditions weren't.
yeah. So right. So you can have that sort of conversation. And it's like, well, why? What is Tile's statistics telling you the problem is here? Is it bias? So if it's bias, you got everything right. It's just that you gotta close it down. You're systematically above something or below something, right? Gives you a place to look, right? So right. And then how good is good? What do you got to see to convince somebody? Because again, we have with algorithms today, you can force the S and the A to be pretty close in most instances. But is it really telling you anything? Probably more than not forcing it to have this crazy fit. Or is it just used to convince a client or a government official or whatever? All right. So the idea, so let's back up. So the big takeaway here, we model a problem from a systems perspective. We don't model a system. We first state the problem my way anyway, not the two Jims, in words. Then we turn the word statement into a graph or graphs of variables over time, which is called the reference mode, right? And we want to make sure that we define, what do we mean by time? Weeks, quarters, years, months, whatever, right? And how long are we worried about here? 5 years, 10 years, whatever, right? 1 year, whatever. And then we want to look at the time shapes over the time span of interest, right? And how the time shapes relate to one another. Does one go up and then the other one goes up, or does one go up and forces the other down at the same time, or whatever? And right, think about it. If you're going 100 years versus 10 years versus 1 year for gasoline prices or oil prices or something that's been around 100 years, what you include in your model, if you're looking at the price of oil over 100 years, is different from what you'd look over 10 years, is different from what you'd look over 1 year, right? Oil discovery and oil rigs, the number of them are probably not important for 1 year. They are important for 10 years or 100 years, right? So it helped, the reference mode also helps you, like, where am I drawing my fence? What can I consider to be constants and what are variables? So anyway, so the reference mode is a problem statement and you wrestle with some of these issues, right? What do we mean by time? How much time, etc.? What are the important variables that are a picture of the problem statement? What are their time shapes? What are their time shapes in relation to one another? Right? Okay, and then later on, after you build the model, you want the base run of the model to look like the reference mode, right? To fit the data. And again, if you have qualitative, somebody hand drew it, it's a qualitative fit. But if you have numerical data, economists, politicians, business people, average citizens intuitively want to see the synthetic and the real data look alike. And yeah, if they're right on top of one another or darn near, you don't need statistical analysis to say the red curve looks like the blue curve. But if they're not quite like that, you saw Sturman's stuff, how do you determine how good the fit is? Well, econometricians, Henri Theil, famous econometrician, came up with a way of doing it. And Sturman says, use it. And we have it all laid out in Stella or Vensim. If you want it, you don't have to figure out how to do it. Later on, we'll talk about discrete versus continuous. If you want every year or every quarter, you got to, and DT is not one, you got to have it skip to get it to the right point. So it's a little bit of treachery to get there, but we don't have to worry about those details at the moment, but just the big picture here of what we're trying to accomplish, right? Yes? Okay, so there's no other issues. So where's my clock? I got 8 o'clock here. You want me to do one more thing, or have you had enough?
I'm done.
No mas.
I have to go do some stuff before it gets dark.
Okay, so next thing we'll do then is just to coming attractions is we will look at when we do a reference mode, problem statement reference mode, right? We also want to be able to determine what better means, or improved means, or solved means. So Jim, you usually advocate, and I know some others from your cohort advocate what hope, fear. What's the terms that you guys?
Yeah, the hope and fear. Yeah, hope and fear.
Hope and fear. So we fear that the bad thing is going to keep growing. We hope that it's going to drop, or whatever the case may be. You want to be able to define what solved means, what better means, what improved means, or what have you. But guess what? It's rarely the case that it's obvious that there's one variable and everything's related to that. Something bad is growing and we change it this way, the airplane, and now the bad thing is shrinking. Wouldn't that be nice? Usually that doesn't happen. Usually what you have is a multi-attribute function, scoring function, that describes all the stuff that goes into good or bad. And if that multi-attribute thing is going up, that's good. And if the multi-attribute thing is going down, it's bad. Often you get trade-offs. More of this means less of that, and vice versa. So you have to think about, on net, I got more of this, less of that. There's all these trade-offs. What do I want to do here? And there's a way. So in the first course, we had a single attribute scoring function, right? We had total number of heroin-related crimes in the heroin model. We had the total cost of the project in the project management model, right? Single attribute. So if the total cost is going down, that's the simulation run that makes the cost go down the most is the best. The simulation run with policies that made the least heroin-related crimes is the best. A single attribute. Now we want to talk about multi-attribute scoring mechanisms, utility functions, right? And how do you do that? And put that into your, so when you got your reference, so the reference mode is mimicked by the base run, okay? Now you try experiment 1, experiment 2, policy this, policy that, and you compare it to the reference mode. how is it doing better than the reference mode or not? And is it, how do you compare one run to the next? And how do you smear that together into your model and into your game? So you have a score for your game when you play. So we'll look at that. That'll be the first thing we look at next time. So finally, I know everybody's kind of had enough. Real quick here. For next time, we probably don't need office hours yet, I'm guessing, but let's take a look at some of the stuff we described here, the tile stats stuff that we went over. And you can start reading ahead a little bit. Let's look at the objective function and scoring metric stuff. And you can also look at these conceptualization things. And here we are with all this stuff. So, I mean, all that, if you haven't looked at it, look at it. And you might want to look at this ahead of time. Look at David Anderson and John Rohrbaugh's paper. A classic one is Andy Ford, who is sick. And Gardner, I met him years ago. I don't remember his first name. One last thing, and I'll let you go. Do I have it here? You'll see as we go along. I thought I put it up here. I guess I ran out of time. You're going to see that I'll post some discussion threads. I have a whole bunch of them that were done by all the luminaries in the field some years ago, including Forrester, Sturman, Moorcroft, Hines, Linus, Eberlein, Homer, and whatever, George Richardson. When somebody would pose a question on a discussion board, how do you do this? How do you make a scoring metric? How do you make an attraction formula? And all of these luminaries in the field weigh in and with different opinions on how to do it best. And they disagree with one another and they go after one another. It's really quite interesting to read all of the stuff they say back and forth and then what's the best way to do something or what have you, right? So we'll be posting that as well, that there's not always one way to do something and not even Jay Forrester's work is agreed to by everybody in the field, okay? All right, let's leave it there. We survived another Mike lecture. So good to see everybody. No office hours yet, right? So Sunday
No.
we're
Correct.
okay. We're still okay. And
Mike-
we're in no rush to cover all this. So
Mike, can you stay on for a minute? I just got a couple questions.
yeah, no problem. All right, so we'll see everybody else
Not office hour type questions.
next time.
All right, bye.
Bye.
Yeah,
See ya.
bye. Take care.
So I was listening to the recording from the previous last week. Oh, you stopped your recording?
Oh,
We don't need to record this.
hang on. I need to. Yeah, how do you do that?
My lighting